Thank you all so much for joining us for CharIN Tuesday on March 4th. We're really pleased to be offering a great webinar for you today on SAE J3400, the next generation of charging in North America. We are joined by a great group of speakers today, including Rodney McGee, who's the chair of SAE J3400, Mariano Rigodi, who's the EV Charging Business Development Director for Amphenol, Martin Suckup, who's the Executive Vice President of Engineering for EVgo, Dale Jordan, who's the Public Charging Reliability and Interoperability Manager for Ford Motor Company, and Ash Wang, who's the EV Charging Industry Analyst for Bloomberg New Energy Finance. Thank you all so much for joining us today. For those of you who are not familiar with CharIN, we are a global association focused on promoting standards in the field of charging systems for all types of electric vehicles, both on-road and off-road. We promote 3 different charging system standards, including CCS, the Megawatt Charging Standard, and the new North American Charging System, which we'll be talking about today. We also promote ISO 15118, which is a form of communication protocol that works with all 3 of these systems. We also promote standards through a lot of different activities that CharIN organizes, including conferences, roundtables, and exhibitions. We have a series of focus groups that we manage that include technical experts from around the world. We also host organizational events like Testables and CharIN Academy trainings, which provide opportunities for people in this field to do actual practical and implementable work with each other to ensure interoperability between these different communication protocols and systems. We are located all over the world with offices in many of these regions you see here. And also we have over 300 members who are based in the EV charging system ecosystem. Here's a little bit of a breakdown of CharIN's value chain. So as you can see, we have members from grid operators, the technical side of IT, EVSC OEMs, electric vehicle OEMs, charge point operators, tier 1 suppliers, and testing and standardization groups. With that, I will turn it over to our first speaker, Ash Wang, who's the EV charging industry analyst for Bloomberg New Energy Finance, who's going to be providing us a little bit of industry perspective and trends as it pertains to SAE J3400. So thank you, Ash, for being with us, and we look forward to hearing a presentation.
Thank you, Erica. Hello, everyone. My name is Ash, and I am the North America EV charging analyst at Bloomberg New Energy Finance, or BNEF. BNEF does research on the energy transition, and within that, I cover EV charging rollout, policy, and commercial activity, as well as our Outlook data tools. So today I'll be talking about the state of SAE J3400 adoption. J3400 is a long overdue fix to the charging plug wars, but its adoption is taking a while. So let's talk about where we stand, the challenges, and what's needed to bridge the gap to a standardized charging landscape. Next slide, please. So North America's EV market has reached a milestone last year. EVs now account for over 10% of passenger vehicle sales. Breaking this down by drivetrain, battery electric vehicles, or BEVs, dominate at 80% of EV sales, while plug-in hybrids hold 20%. But growth has slowed. The 4-quarter moving average plateaued in 2024, and BEV sales dropped to below 300,000 units in the first quarter of 2024. And EVs are still faring better than ICE vehicles, though. The year-on-year growth in EV sales has been greater than that of ICE vehicles every quarter since 2020. And it's notable that Canada is seeing strong growth, with almost 17% of cars sold in the third quarter last year being electric. Next slide, please. Okay, but placing this in a global context, North America is falling behind. EVs in China and Europe are at 48% and 25% of passenger vehicle sales. These are driven by government subsidies and public charging networks that are abundant and reliant. China's EV sales in 2024 are expected to be over 11 million, and this represents over 65% of the global market. Europe sales are expected to be 3.2 million in 2024, and this will likely grow in 2025 as automakers push to comply with fuel economy targets. And even South Korea, which is this light green line over here on the right, at 14%, EV sales share is higher than that of North America. Without a surge in EV adoption and infrastructure deployment, North America risks falling even further behind the largest players. Next slide, please. So Tesla has been known as a dominant player in the US, but its dominance is wavering. For years, Tesla has provided more than half of the country's battery electric vehicle sales, and its market share hovered around 80% from 2018 to 2010. But last year, Tesla had just 48% of the US EV market, down from 57% in 2023 and 65% in 2022. And its aging model lineup is not helping. Its biggest competitors are here on the right. GM lifted its sales 50% last year for new models and the increase in popularity for its Cadillac Lyriq. Ford sales rose 30% despite not releasing any new EV models, and Honda's market share went from 0% in 2023 to 3% in 2024 from 2 new fully electric models. Next slide, please. To meet 2030 demand from EVs, the US's public charging network must ramp up to install chargers at a rate 10 times faster than we are doing today. So in 2024, the country added just under 40,000 connectors, and this needs to grow to 400,000 per year by 2030 to bridge the infrastructure gap. For comparison, China installed over 20 times more chargers last year, and Europe installed 6 times more than the US did. All right, next slide, please. So we know that Tesla dominates charging in the US, but it's very different in Europe. Tesla's supercharger network remains in the lead with 70% of the ultra-fast connectors in the US. Its competitors are expanding, but in Europe, Tesla has a much smaller share of the market, with over 500 competitors playing in the sector. The playing field of charging in Europe is much more developed and diverse than the one in the US. And part of the reason for this is that the EU adopted CCS2 and Type 2 charging as its standard a decade ago. And the certainty that CCS2 fast chargers would be able to be used by all the cars allowed charging networks to grow rapidly, which helped increase competition in the space. Next slide, please. All right. And in the US, there are 41,000 ultra-fast connectors and 144,000 public AC connectors. Most of these are not J3400 connectors. Over 20% of public fast chargers in the US are CCS connectors, and over 80% of slow AC chargers are Type 1. So we'll be watching the movements of charge point operators, or like ChargePoint, Blink, EVgo, and Electrify America to gauge the progress towards full J3400 adoption. And retrofitting existing CCS stations with J3400 is costly for these operators, so progress could be slow. And we'll talk about this in more detail later slides. Next slide, please. Okay. So all major automakers have announced commitments to adopt J3400, but few have actually made the transition. Hyundai's Ioniq 5 and Lucid's Gravity are the only vehicles that are selling with the factory-fitted J3400 connector. But other vehicles like the 2025 Kia EV6, BMW i5, and Rivian's R1T and R1S are likely to feature J3400 ports and be released within a year. Many automakers have stated that they will have vehicles with factory-fitted J3400 connectors this year, but some, such as GM, have revised the timeline back to 2026. And this part of the reason for this is that fitting vehicles with these ports can be difficult and expensive because the ports require different wiring and placement, sometimes it's CCS ports. And Tesla's firing and partial rehiring of their supercharger team staff may have added to automaker delays. To give customers access to Tesla's large supercharger network, in the meantime, automakers have been providing customers with CCS to J3400 adapters, but some of these have had recalls due to manufacturing defects, and EV owners are also reporting frustration with issues like overheating adapters, reliability, inconvenience, and gaps in compatibility with third-party adapters. So Tesla currently accounts for 30,000 out of the 45,000 or so ultra-fast connectors in North America with its supercharger network, and 8,000 out of the 168,000 AC connectors are also Teslas. But all of these have the J3400 connector, but non-Tesla vehicles can only charge at a selection of V3 superchargers or newer models, and this subsector comprises nearly 18,000 charging stalls as of the last time I checked this month, and it's growing. The older V2 charger models use a different protocol and are incompatible with non-Tesla vehicles. And next slide, please. On the charging infrastructure front, a lot of announcements are being made in which operators are planning to roll out J3400 cables, but few actually have them in operation today. Iona, which is a joint venture of major automakers, has a handful of stations open with J3400 connectors, and Rivian's Adventure Network will have J3400 connectors as well. Electrify America still doesn't have any J3400 cables. They're stuck in the planning stages. And so there's still a long road ahead to full interoperability. So adapters are not going to be going away for a while. Yeah, I think I'm running a little bit over time, so I'll just leave it here. I think J3400 is the foundation. We see it as the foundation for North America's charging infrastructure landscape, and we hope to see standardization accelerate in the future. And with that, I will pass it off to Rodney from the SAE.
Thank you so much, Ash. That was great and a fantastic start to this webinar to give us a little bit of an overview of the landscape. I now want to turn it over to Rodney McGee, who's the chair of SAE J3400's committee and also affiliated with the University of Delaware. Rodney, I'll turn it over to you. Thank you so much.
All right. So I'm going to give an update on where we are with the standardization of NACS. Brief, go ahead and get into the first slide here. All right, so the standardization process kicked off, a few weeks after the Ford announcement and GM announcement, etc. And within that first year, we published our first standardization document in December 2023, which was our technical information report. We turned that around the following year into a recommended practice, which is our next level up in document maturity. And I think that's all I want to say about this slide. So there's some, the way I kind of like to explain it is, J3400 is the standardization of the NACS charging system. So it's in the title. And so many people might be curious as to what the differences are between the connectors. And so the connector on the right is the 1000-volt J3400 connector. Connector on the left is the legacy NACS connector. We also kind of refer to them as the 1000-volt or 500-volt connectors. Primary difference is some material is removed to increase creepage and clearance. I should note that, when you compare NACS to CCS1 or CCS2, in terms of DC charging, generally compares pretty well. Have a very similar actual, despite the connector being a bit smaller, substantially, it actually has slightly larger socket size. So they should perform pretty similarly. It's mostly limited by the design and the engineering of the connector and the cooling systems. So at this point, both versions, headset, little problem there. Both versions are deployed We have a few 1,000-volt capable NACS deployments at this point, which kind of supports vehicles with higher voltage. But most of the connectors currently deployed are the legacy connector. We require full interoperability between those two connectors. So essentially, you can plug them into each other. And as was talked about earlier in the previous presentation, any DC charging application that meets our baseline interoperability class, which would be, your generation 3 or 4 superchargers, in addition to any of the third-party chargers coming onto the market that comply with the standard, those all are interoperable. With AC applications, there's interoperability between the existing NACS stations and new NACS EVSEs, which meet the requirements in the standard. So that's kind of an overview of where we are with the mechanical coupler side, just to go over some of the basics. Next slide. So I wanted to just mention a couple, scenarios. There's kind of, people have these two streams in their mind, which is one that they know, for example, that, not all superchargers are available to third-party cars. And we talked about that in the previous slide, but there's a number of scenarios in which a vehicle's following standards, you could possibly connect them to a charging station you can't charge to. And it was mentioned earlier that obviously the, 8,000 or so Generation 2 supercharger installations are not open to other vehicles because they don't speak the CCS protocol. There are a number of situations where the vehicle, which maybe wasn't quite following the CCS standards correctly, could do something to be incompatible, ironically, on the NACS network. That's the first bullet. So that in and of itself leads to some incompatibilities. There are some public charging stations that don't allow you could say non-Tesla vehicles, but it's a little more technical than that. They may be specifically configured to only allow certain vehicles to charge on them. Also, another thing to think about is adapters aren't universal. So an adapter that's appropriate for an AC station is not the same one you would use for DC charging. And so it's really important, I think, that most OEMs are communicating with their drivers very carefully about what NACS stations are open for them with their adapters. You can't just say if it plugs in, because not all switch to a different microphone as my headset was malfunctioning. There are existing NACS AC stations which are incompatible with some existing J1772 vehicles. So I think, the point is that you need to communicate with your drivers about what NACS stations will be open to them, when you're getting into a new charging network. Next slide. So there are a couple of the manufacturers who are sort of farther along with the process of upfitting their stations, brought up some issues that we thought would be helpful to communicate to those that are a little newer to NACS. So in North America, under SAE 1772, it's required that the DC charging stations monitor the state of the proximity signal on the vehicle. That's part of our SAE standards, has been for over a decade, but not all DC fast charge stations in the market support that function. And especially ones that were maybe originally designed for CCS2, especially don't necessarily do that. So there are concerns, for example, if you don't follow the requirements in SAE 3400, which again are consistent with the 1772 requirements, and a customer uses the wrong adapter, it could cause damage to the vehicle, because kind of two things happen. The customer used the wrong thing, but you didn't implement some of the requirements that actually prevent that scenario from happening. The next, let's see, the next situation would be that, go back one slide. Yeah, the next situation is that NACS connectors kind of have a stop button on the cable, on the connector, and that button under J3400 actually goes all the way back to the charging station. So it's like that stop button on the screen, but it's on the connector. Another thing is that charging stations complying with 3400 are adapter aware. That is another kind of software change that needs to be addressed in the vehicle. So best case scenario, if you were following SAE J3400 standards, and you have a place to connect a stop button inside your station, mainly the thing you need to do is implement awareness of adapters so that you can prevent thermal shutdowns and provide a better experience. The other thing I would mention is there are dead fronts on the connectors that are optional. That's because some stations integrate de-energizing the cable when unplugged as part of their overall safety system, and so they don't rely on mechanical features on the connectors to prevent contact with the sockets. Next slide. So items that we're currently working on, we have an adapter document that is open. We have, and that is probably going to be published soon. It's sort of in the later stages of balloting. We have taken just the coupler part of J3400, and we've moved that into its own document. That will allow us to move forward with finalizing some of the mechanical aspects of the coupler while we wait for these communication standards that we intend to incorporate in the 3400, such as ISO 15118-202, the so-called Extended Service Discovery Protocol, which allows for the possibility of North American charge roaming in actually kind of sort of an open and interoperable way that hopefully reduces the need for extended technical work to sort of onboard people onto each other's charging networks. Another kind of feature of the current NACS system that's not part of a lot of existing implementations is arc detection. So there are some technical capabilities of superchargers that relate to the reliability. And so we want to describe as many of those in the standard as possible to allow manufacturers to implement these functions. Next slide. Another thing kind of related to public charging infrastructure is J3400's recommended practice, and actually the technical information report published in 2023 made it clear that within North America that you could have bring your own cable AC charging. And so the idea with this is that through bring your own cable, you can simplify the infrastructure required to be maintained in public spaces, and also not have to worry about having two different AC connectors because the customer carries the cable that's appropriate for their vehicle. So I think we might have a speaker later mention a little bit about this, but that's the main topic here. Next slide. So the next thing I kind of wanted to point out, which is kind of related to the previous slide, is things that we're doing with NACS to lower something we're keeping that was supported by the Tesla system that we're maintaining in the standardization of the system, which is support for all common US single-phase voltages that are delivered by the utility. So J1772 vehicles were required to support 3 of those. NACS supports all 4. I think I usually like to make this point by saying we were the only country that couldn't supply our DC fast chargers using the same grid connection that we connected our AC chargers. So that's the case in most countries that, 400 three-phase, 230 single-phase power that supplies most DC fast chargers in Europe, that same feed can be used for AC charging. In the US, requires a whole second set of infrastructures and transformers for AC charging versus DC charging. So in NACS, that's eliminated, meaning the same stuff that you use to power your DC fast chargers from the utility can power your AC stations. Next slide. And then this is just an example of how that affects cost. In the US, commercial sites that get a certain power level, that may be a 0.5 megawatt, that may be 1 megawatt. At some point, you'll get to a certain power level for a site where they'll tell you, you're getting 480 volts, 3-phase power, and that power previously under J1772 could not be directly utilized for charging vehicles, AC. It can be under 3400. So when we're talking about electrifying, the other, the existing ICE fleet, where those cars will be NACS cars, and you're looking into the future of urban charging and large electrification of parking facilities, this is where this really pays benefits. In the short term, we don't expect a lot of public charging stations to use this kind of capabilities, but it's really something we had to decide in standardizing NACS to what would be, whether this would be something we retained that Tesla vehicles supported going forward in the standardized implementation, which we chose to retain that because it paid dividends long term. Next slide. I think that's it. All right. Thanks.
Thank you so much, Rodney. For those of you who are joining and may have questions for any of our speakers up to this point, feel free to drop them into the question and answer section of your webinar tabs, and we'll get to them at the end of the presentation. Next, I'd like to introduce Mariano Rigodi, who's the EV Charging Business Development Director for Amphenol. And Mariano, I'll turn it over to you.
Hello, everyone. I'm Mariano from Amphenol. Amphenol is one of the leader manufacturers by far worldwide for EV charging. What I'm going to focus in this slide and in my presentation is going to be about the benefits, the pros and the cons between this transition. We're going from the Type 1 CCS1 onwards, the J3400. I will not consider the CCS2, even if it will be interesting, because it's not the scope of this presentation. CCS2 actually is capable of doing 3-phase charging on AC. That is very interesting, but that's not the focus of today's presentation. Now, I split in this chart different capabilities on each of them and the benefits or not. Regarding the max voltage, as you can see, the Type 1 is 240. And as Rodney mentioned, the J3400, that is the last one in the right, is capable of doing 277. That enables you to actually have a cheaper installation compared to the J1772. The other key thing is the moving parts. Type 1 and CCS1 unfortunately have a moving hook, that anything that moves is prone more for any failure in any connector that you design, even if you do it as rigid and rugged as you can, is still more prone to failure. J3400 and the Tesla Legacy actually do not have moving parts similar to the CCS2, so it's actually way better for a long-term reliability. The other thing that is way better in the J3400 is that by standard, we are requiring the couplers to be locked in the J3400, while in the Type 1 is optional. Making it optional, theoretically, when you press the button in 100 milliseconds, is supposed to turn off the power. However, we have seen that in less than 25 milliseconds, people are able to unplug it, and you create a hot disconnection that unfortunately impacts the performance of the contact and eventually in the long term damage the infrastructure. So that's a better thing that is better defined in the standard of the J3400. The other thing is that the stop button of the Type 1 actually creates an emergency stop, while in the DC J3400, it makes a normal stop process because it's locked. And this enables you to have a longer life of all the hardware in the charging system. The other thing is that the adapter itself is defined in the J3400 and is defined how you can operate better with an adapter, how you can fold back the current if it's required by the adapter because of a temperature rise, and how an adapter can even protect itself. In the J1772 or CCS1 is not defined. The fallback current is what I mentioned about the adapter. It's properly defined, and it's going to enable the infrastructure to know that there's someone in between the vehicle and the EVSE that is having problems and will require to charge in a lower current because it's not capable of doing so much current. Now, not everything is great on a transition to NACS J3400. The connector, yes, is slimmer and nicer or lighter or smaller. However, it does have less protection for impacts, and especially on the 1000 volts, that less material is in there. It's when it's expected, even if you selected the most hardest material, that eventually an exposure to metal is easier to achieve on the J3400 because there's no plastic in between the contact, while in the CCS1 there is. So that's more or less the comparative. The other thing that it was already explained by Rodney is there's difference between the Tesla legacy and the new J3400. Please consider that the Tesla legacy just charge up to 500 volts for DC, while the new standard it's for 1000 volts. The infrastructure that it was mentioned by Ash in Bloomberg, that is a fast charging infrastructure from Tesla, unfortunately currently usually charge at maximum 500 volts. The new standard actually is capable of doing 1000, so all the other networks will be charging at 1000 volts, and that's way more advantageous for a lot of vehicles to charge twice faster. Next slide. Going to keep it short because it was already introduced by Rodney, but it's basically if for AC you don't know what infrastructure to build, you want to build one that is going to help you the transition onwards the J3400, you can actually use the J3068, that is the new standard release last year, that enables you, as in Europe, that is already a success for AC charging, to have an outlet. It will be a Type 2 outlet, and it's going to be to enable you to actually plug any cable you want. Now, it is very important because also it takes out of your maintenance program the cable assemblies, because it's easier to replace or to change. You will eliminate adapters. You will not have cables on the ground. You are not going to expose impacts on those cables. They are not going to be under snow, etc., etc. So it's great solution for curbside charging, parking lots, condos, apartments, or mixed use EVSE level 2 that you think you require a transition and you don't know what mix. So this will be the solution. And that's it. So I will let the rest of the presentation to move forward. Thank you very much.
Thank you so much, Mariano. We really appreciate that overview. And I did like the Lord of the Rings reference there as well. It was really cute. I'll turn it over now to Dale Jordan, who's the Public Charging Reliability and Interoperability Manager for Ford Motor Company. Take it away, Dale.
Thanks, Erica. Yeah, I wanted to take some time to talk about the human factors. A lot of people have been talking about the technical side of things and the ins and outs of that, but I feel like there's not enough focus on people. Ford's done some analysis that shows that human factors actually have a really big impact on reliability of DC fast charging. Specifically, new customers have a lot lower success rate than existing customers, which tells me customers are having to learn the hard way over time. So we're really trying to think, how can we make things easier for our customers? Really, the big thing about J3400 is right there in that photo in the bottom. Looking at the size difference from it and CCS1 is huge, but then also the consistency of the user interface. Right now, most people on a regular basis, about 90% of the time, are charging on level 2, and that is the J3400 plug, I'm sorry, J1772 plug. And they'll go every morning and push their thumb and unplug. But then they go to a DC fast charger, maybe for the first time ever, maybe for that once-a-year road trip, and it's a completely different interface, a totally different experience. And it may seem easy to those of us that are experts, but the reality is it's not, and we see that people are really struggling. So we're excited that the migration to J3400 will create a single user experience, whether you're at home or out in public. Obviously, there will be a transition period, but moving to just one consistent plug shape in the future, we think will have a big impact to the customer. Similarly, how do you actually plug that thing in? The CCS1 connector is huge and heavy. And if you look actually in this photo, it's different for everyone, but the NACS connector is smaller than the handle of the CCS1 connector. I don't have to tell anyone how hard it is to plug in, and we see data that shows how often people fail to plug in all the way, and that can be lower with J3400. So really excited about the transition. Certainly there's going to be a transitionary period, but in the long term, I think the end state is going to be better for the customer, not just for the technical reasons about power capabilities, but also the user experience. That's it.
All right. Thank you so much, Dale. We'll round it out with our final presenter, Martin Sukup, who's the Executive Vice President of Engineering for EVgo.
Thanks, Erica. Thanks, Dale. Yeah, so just to give a little bit more perspective on what charge point operators are doing and how at least EVgo envisions it. So basically, up until now, the public infrastructure has been CCS, but of course, as we've been talking about, we're transitioning to NACS. And, overall, I think the goals that we're trying to do with this transition is, first of all, just get to a common industry standard as quickly and smoothly as possible. And, we all recognize the kind of advantages that can give us. But I think with the overall way I would summarize that is just that it signals to the industry that, that we're mature and we're kind of ready for this, that all of these kind of which protocols should I use, which connector should I get, and all of that. The sooner we can get that in a rearview mirror, the better. It's just less confusing for customers and ultimately furthers EV adoption to have that settled. The other challenge, though, that we face is how do we support our existing CCS users while still attracting new NACS customers? So that's what we're really trying to do is do this transition, but not leave anybody behind. And so how we're approaching that is basically by taking it slow and being gradual. We want to kind of use retrofits as a way to start to introduce NACS to our network. At the same time, we have the opportunity to do new builds with NACS as well. And what we're doing is basically monitoring usage while this is happening and just making sure that the mix matches our user demand. And, that kind of comes in two ways. First of all, you need to make sure that new NACS drivers or Tesla drivers are aware that they can come to your network and charge, which isn't always easy, right? If they're used to going to Tesla chargers, they might not even be, have your app or even be on the radar at all to be looking at you to charge their vehicle. And so getting that awareness is something that you want to do, but at the same time, you have to be careful to not advertise too much and have it overwhelmed. At the same time, if you're doing retrofits, that means you're changing a charger from a CCS to a NACS charger. And so people that were used to using that site, maybe using that particular charger, are used to going up and if they have a CCS vehicle, just being able to use it. And now all of a sudden that's changed for them. And so we need to make sure that we don't push too hard in that direction. And all of a sudden people are again kind of not sure what to do, where can they charge, what's going on. And so really it's just about being gradual to do that. Many networks have started to do that today, as some people earlier discussed a little bit. Some people are being more aggressive and some are less. So, the precise mix that the different charge point operators are taking, varies a little bit, but they all seem to be at least, moving in that direction. The other kind of important timing thing that we see is that we think that, and Ash touched on this as well, we think that, most majority of vehicle OEMs will be native NACS by 2027. Those timelines, of course, have been moving around a little bit, but we do feel pretty confident that within the next couple of years here, that's really going to settle out. Also touched on by some of the other presenters is when we are doing retrofits, what are some of the challenges we're seeing? The handle button was mentioned. Sometimes it's referred to as the S3 button. And it basically could lead to an interoperable button that, with CCS, it's part of the proximity circuit, but it basically signals an emergency stop. Whereas with NACS, it can be a normal stop button, which is pretty convenient for people to use. They need to go and remove the connector from their car anyways. Why not just do it in one step instead of needing to press a button somewhere else to stop charge and then go unplug it. So it's a nice feature we want to take advantage of. But if the stations weren't set up for that initially, you might not have a place to land those S3 connectors for NACS. And so you could end up with a button that's just not doing anything, which obviously is confusing again for the customer. So want to avoid that as much as possible. The other thing that Dale was pointing out was kind of the different shape of the connectors. And what that can mean is different angles and cables coming out in directions that they weren't coming out before. So that can just make things a little bit more complicated, and you might need to also update your holster or your cable management a little bit to deal with that. Some other kind of interesting things are places where the industry might be able to align to again, make this smoother for customers. One thing that we would recommend and that we're doing is that we use the outlines of the connectors to help give a visual identification for the users of what kind of connector is native to that charger. So on the right, you can see a NACS and a CCS outline that's just really easy to recognize. The other thing that you might have noticed in this presentation is we don't have common terminology yet. Some people say NACS, some people say J3400, some people still going to refer to it as Tesla just because of its roots. And even for CCS, people will call it CCS1, Combo 1, Type 1, and things like that. And so if we can use common terminology, that will help customers not be confused and say, well, is it NACS or J3400? Which is which one do I have? I think, frankly, less likely to be successful, but similar to the way gas pumps have green for diesel, if we could come up with common color coding across the industry, that might also be really convenient for customers. But with different companies having different branding schemes and colorways and things like that, it may be a harder sell to get people to agree to a certain color, but we could at least have the discussions. Finally, as has also been touched on, I think that we're just going to have to accept that adapters will be used by customers. As much as we're going to try and get the right mix of native CCS and NACS connectors on the networks to match the vehicles, basically people are still going to probably show up to sites and see that all of the NACS connectors are used and the CCS connectors are open, and so they're going to go there even with a NACS vehicle and need to use an adapter and vice versa. And so, what can we do to make that user experience as nice as possible and as safe as possible for the users? So one thing that we definitely recommend is to only use adapters that are supplied by the vehicle OEM. for that particular vehicle model. That's a great starting point, because now you don't have to worry as much about potential differences in voltage, differences in current rating of the adapter. Maybe the adapter, wasn't supplied by the vehicle OEM and doesn't have some of the approvals and protections that it should. So really that's what we recommend as the starting point. We also definitely want to push for UL 2252 approval for adapters. It basically, gives you that standard level of safety that we think is necessary, in particular, having the thermal protection. We also, as Rodney mentioned, would encourage the adoption of the ESDP, the advanced diagnostics, and this can help you do a lot of things. Once you've identified that an adapter is present and you know some of the other ratings of the vehicles and the charging equipment, you can do things like fold back to keep everything safe for the customers. So it's an exciting time, and I'm really happy that as an industry we're making this transition. And we just want to try and do everything we can to make it as smooth as possible and get through it quickly. In the end, I think it's going to be great for EV adoption.
Thank you so much, Martin. And with that, we will welcome everyone back to share their screens so we can see your lovely faces. I am also going to close down this presentation for the time being, but if you guys want to reference any of your slides, I'm happy to share my screen again. I have a few prepared questions before we launch into questions from the audience. For those of you who are joining us online, please feel free to put your questions into the chat box and we'll try our best to get through all of them. We already have quite a few. But first, I wanted to do a little bit of a crystal ball exercise with you all. We talked a lot about the transition, but we didn't really talk about timeline for the transition. So I was curious if anybody would like to make a comment on what they think will be the timeline by which we'll see a transition fully from CCS to NACS in North America. If we will ever get to that point, I'd love some extra kind of forecasting there and hedging on how you're coming up with your numbers. So would anybody like to get us started?
I can.
Martin, why don't you start us out?
Sure. I was just gonna say, obviously crystal ball, and we're all kind of feeling our way around here. I mean, I think that full conversion is not likely for a long time, just because of the vehicles on the road today. That there's a lot of CCS vehicles on the road, and they're going to be driving around for a long time. But I think that in the next again, just guessing, around the next 5 years or so, I think we would see a really large majority of vehicles in operation and charging stalls as NACS. And that, at that point, I think while you go through that long tail of transition, you're just going to be more and more, the CCS vehicles will just kind of be more and more dependent on adapters to utilize the infrastructure as it continues to shift more and more NACS.
Thanks, Martin. Rodney, you were going to make a statement as well?
I was just going to say, I mean, the best analogy to give is probably CHAdeMO, right? There are new CHAdeMO stations being installed right now. This year's model Leaf, it still has a CHAdeMO port. So just think of CHAdeMO. There's going to be people using CHAdeMO stations we're installing right now for years to come, but it's going to become a smaller and smaller part, and it'll also be a smaller number of customers being served. So it's a very long tail. So zero is a long ways away.
Erica, you're in mute.
Oh, thanks, Mariana. I wanted to ask, does anybody else want to make a crystal ball forecast?
So the transition already started, and it's going to take us at least until the last CCS1 car is being driven. So at least 10 years.
And I drive my cars into the ground. So yeah, 15 years for me. All right, next car. Or sorry, next. Sorry, go ahead, Dale.
I would just add to that the one thing this industry has been very consistent about is being completely unpredictable. So definitely stay agile, because the one thing that has been shown is no one can predict what's going to happen in the EV industry.
That's true. That's true. That's why I love this industry so much. Next question. We didn't talk very much about medium and heavy duty vehicles on this call. So I'm curious to understand what you think will be the transition timeline between passenger vehicles and the medium and heavy duty segment. Will they transition at all?
So, oh, Roddy, I think you
Roddy?
have the mic. Okay.
Yeah, go ahead, Mariano.
So medium and heavy duty is actually a big market. For sure, the heavy duty is going to go onwards the MCS, that is the megawatt charging system that is being released right now. It is the same standard and geometry that will involve almost everywhere worldwide, including Europe. So that's on the big trucks, right? For the heavy duty. For the medium duty or delivery vans, there might be a small business cases that NACS might be implemented as well in there, but it's going to be a case by case situation depending if it's more last mile delivery van where it's being charged. Usually they are being charged in depot charging, and not in public infrastructure, so it doesn't matter much. But it's expected to. I mean, the MCS is capable of charging more than 3 times faster. So if you can take advantage of it, is the market to go forward.
Sorry,
Erica, you're
Roddy, is your mic working now?
Yeah, I was just going to add that we're trying to make some adjustments in megawatt to allow that 800-volt class battery packs be able to be served by MCS. And if you do that, you can get people who don't necessarily need megawatt power levels today onto MCS inlets at CCS at CCS power levels, which will essentially get them on the right inlet, so that when they want to go to the more aggressive use cases, transit buses operating 23 hours a day, stuff like that, they already have the right inlet. Because the fact is that CCS1 doesn't serve medium and heavy duty well for AC or DC charging, so it doesn't do the 3-phase AC that's already a part of the diesel reefer and all that industry that uses 480 to take off the vehicle load. And then it also doesn't serve the DC power levels we need to have fuel equivalent. So the quicker we move off of CCS1 for medium heavy duty to connectors for that industry, the quicker we'll have growth there, actually, in my opinion.
Thank you, Rodney. Any other comments? All right. So my final question for you guys before we move over to the audience questions: will the SAE J3400 standard be used outside of North America? And if so, where?
There are plenty of places that use Type 1 today. South Korea and Japan, Taiwan use Type 1 NACS a little bit here or there. And those countries are already sort of attending the standardization meetings. There have been some commercial announcements, like with Sony and Honda, on using NACS in Japan. So any place where they're currently using the Type 1 or NACS, which there are a number of countries, would be places where you would look for possible NACS usage as defined by 3400.
Yeah, I think really the driver there is just countries that have a lot of single phase infrastructure, because NACS is kind of lends itself to that. So that's, I think, why some of those other countries outside the US would be good candidates.
Okay, great. We'll move to the audience questions next. There's a question about risk of bring your own cable approach shifting burden to EV drivers at a time when new vehicle purchases are challenging for some. They mentioned cables can be stolen or damaged, and it requires EV drivers to stow the cables, maybe during possibly bad weather. So does anybody have any comments about bring your own cable in this context?
So I think it's kind of the choice between having a fixed cable carry alone is kind of a false narrative. There are places where you just won't have AC charging infrastructure if there has to be a permanently installed cable. Okay, so the really hard places to install EV charging, where public space is very protected, where you have street sweepers and other kinds of equipment that need to maintain the ground, snow plows, things like that. Public spaces, parking garages. It's not really a choice between the perfect charging station, which may be the one where you don't have to have anything or do anything. It's a place where can we have more places for vehicles to plug in when they're parked so that we can have better utilization of excess renewable generation. And to do that, we have to minimize the cost of infrastructure. I would also say that if a cable is attached to a charging station and it gets wrecked, that's a service call, that's roll a truck, that's a technician. Carry-along cables are commodities. So the cost to electrify for society is less when we don't have to have specially trained technicians replace a cable through a cable gland, tighten it all down, versus I ran over my own cable or whatever, and I replace it. Someone still has to pay that cost. I think there's less of a cost when you turn it into a commodity rather than a liability.
Also consider that you have different power levels, and depending on the power level you plug, the charger can identify how much capable that cable is. So you're not going to over demand power on a cable that cannot deliver.
The next question I wanted to flag, is there any concern with legacy J1772 vehicles charging at 277 volt NACS in the future with an AC adapter?
So the feedback from the manufacturers is that essentially what you get is a no charge event. And the reason why I brought up all the different ways in which you could plug something in and not having it charge, actually 277 is the least likely one of all of those. Many of those other ones I mentioned, customers thinking they can charge off Gen 2 superchargers, legacy J1772 vehicles that are confused by the initial NACS handshake. Those are actually affecting a lot of legacy vehicles. So 277 is kind of like an obvious one. You say, oh, it's not compatible from an electrical perspective. But we have situations with NACS stations where they can't even if the electric feed was different, they wouldn't be able to charge. They don't have the communication. So again, 277 as a baseline requirement for NACS is really about future electrification. If you want to install public infrastructure that can charge J1772 vehicles, you can't assume they have an adapter, a carry-along cord set, or anything. You need to deploy J1772 infrastructure. If your number one concern is that compatibility, that will mean that then you install within the 240 volt limit. So if you install a 277 volt station and the J1772 car has an adapter and they can't charge with it, there are other situations, like I mentioned, that are more likely to cause that, because by the time we're deploying 277 as public infrastructure, we expect that to be when outside of private fleets, where it really saves a lot of costs, we expect that to be further along in the NACS transition. So charging service providers should install the infrastructure that they believe charges the most number of their vehicles. So that's basically gets back to, if you want J1772 cars to charge, deploy a J1772 connector, because they might not have an adapter. They might not work with whatever the situation is if it's a NACS station. 277 is just one of those. There are a number of reasons. A non-native connection might not work.
Thank you, Rodney. Well, we are at time, and unfortunately, we did not get to every question, but we'll do our best to answer these questions following the webinar and send those out along with the slides and the recording to all registered attendees later this week. So please stay tuned for that email. I got another question here. What should policymakers and regulators be considering in the transition to J3400? And I wanted to flag that we do have a second webinar coming up April 22nd that will address these and other policy and regulatory topics. So please sign up for that on the CharIN.global website if you haven't already. And we look forward to seeing you next month. So thank you again to all of our wonderful presenters. We really appreciate your time today. And we will be in touch with all of our audience. So thank you again.